Hi, my name is Thomas, and in this video I'm going to talk about my thesis, going deeper underground using accelerometers on mobile devices to enable positioning on underground public transportation systems. I've done this thesis at Hasselt University under the guidance of Professor Dr. Johannes Schöning. In the thesis, we describe a novel technique called subway positioning system, which allows localization on underground public transportation systems by only using the accelerometers of mobile devices such as smartphones. As you all know, GPS does not work underground, and most solutions require infrastructure such as routers being placed inside the environment, which is not suitable for large underground transportation networks. So how does it work? It uses general acceleration across all axes. This data passes through a low-pass filter. Then we use acceleration synthesization to combine all these axes into a single data set. We take a rolling average and do stop detection by checking the data with a certain threshold. Then we compare this data that we have to a relative train schedule. So to test Subway PS, we created an Android application called Metro Navigator, which was created and tested in 4 different cities, namely London, Minneapolis, Brussels, and Cologne. Metro Navigator is a GPS-like application that allows users to be guided through underground public transportation systems which they are not familiar with. As such, the application gives users information about how many stations left to their next stop, how many minutes left to their stop, information about points of interest, etc. There also was a smartwatch version created. We find in our evaluation that Subway PS detects 85% of all stations, which is 30% more than other techniques. Also, it achieves a trip-level accuracy of 75%. In our user tests, we found that 15 out of 16 participants expressed a positive opinion, with the main advantages of Subway PS being the ability to be guided to their destination and general location awareness. Finally, in a baseline comparison, we found that Subway PS is 30% more accurate than static timetables and 25% more accurate than proprietary techniques used by official subway networks. And I'd like to thank my promoter, Johannes Schöning, Hasselt University, and of course Alcatel-Lucent for seeing the potential in my thesis.